Welcome. The following video represents my current thinking on the best way of dealing with risk factors and the weather module. And this is the reason I think this video is necessary is because currently PERTmaster, or Primavera Risk Analysis, does not permit simultaneous concurrent utilization of both risk factors and the weather module. And in my opinion, this is a significant limitation that has to be addressed. And so what I've proposed is an attempt to deal with that until Oracle comes up with a better method. So this is our situation. The weather module and risk factors cannot be run simultaneously. This is on version PRA 8.7.54. And next iterations might have this dealt with, but so far this is the current situation. So in this particular situation, we have a 600 activity for your construction schedule that's going to be impacted by both rain, estimate uncertainty, and productivity factors. And so we have dealt with estimate uncertainty before by our R codes. You've seen that, and you'll see it again. But my position is that weather will have a significant impact, and we just cannot ignore it. And also in this particular case, I'm looking at some productivity factors, but they could be any risk factor that you might come up with. That also needs to be incorporated within our analysis. So here's our methodology. We went out and found out what the average rainfall is for this particular area. And in this particular case, the criteria is that the rain day had to have a significant amount of rainfall. I'm calling that 0.2 inches or 5 millimeters. And we're also, because this is the Gulf Coast and we generally work 5/10s, we have a make-up Saturday for all that. Now, sometimes there's going to be more rain there than there are make-up Saturdays, and we have delays. So from this, we're now going to develop a duration adjustment factor, which I'm calling PERT-X, and you'll see this more clearly when I go to the spreadsheet, to account for rain days. And we're going to take that rain factor, PERT-X, and we're going to apply it to all the activity durations via the budget hours. And then we're going to perform the normal risk analysis on the adjusted schedule. So let's go to the spreadsheet. Okay, this is where it starts. And this is the particular database that I used for average rainfall. I recommend it. It's called weatherbase.com. And here in this particular case, I'm using the 0.2 inches or 5 millimeters to model what I'm calling significant rain days or a possible rain delay. So here's our average rainfall, and then from that we come up with the worksheet here, which is showing the total days less the number of Saturdays in that particular month, giving us a likely date, and then I'm saying to model this, I'm doing the minimum is 2 days less and the maximum is 2 days more. And from that, then we come up with a work table, and from the work table it gives us our rain day template, which we'd normally use in the weather module. In this particular case, we're not, so you don't have to do this, but I always use the weather module to check my to see if my factors at all make sense here. And again, the caveat is I've only done this once. But when I did it, I was really pleased with the results. So if we count up all of the days from essentially the 1st of July of 2013 to the 25th of August of 2017, then it's 76 days with a minimum of 15 and a maximum or a potential maximum of 173, or what we're using, a P90 of 173. Now, I took that 76, added it to my original duration of 115, and I came up with the 9th of November. And if I looked at 9th of November, then I had I had 3 additional days for the average, and essentially 8 additional days for the maximum. Then what I did is just did a simple PERT on that, which is the min plus the max plus 4 times the average, divided by 6. And that gives me 85 days. Now, with the 85 days added to the original duration, I came up on 1,601 days. and then get that adjustment factor. It's 1.056. And that's what you need to know. This is all we have to do within Excel. Okay, this is what we now have to do in P6. So this is our original schedule, the gasifier. And what we're going to do here is, and you'll notice our operational date is 25/6/17. And we're going to hit this with a weather adjustment factor. And here is our 1.056. And so what we would do is just apply that to all of the associated activities. And we have already done that. And we now have a 20 November 17 date. So we're essentially done here. All we need to do now is make an export of an XAR file and then bring that into PertMaster. Okay, this is where we work our magic in PertMaster. And as you'll notice, this is our schedule with the expected finish date, the deterministic date of 20 November. Already have accounted for schedule uncertainty in the quick risk template, and have assigned the risk factors to these different things. And we did this before. I didn't want to go through it again, but it's a fairly simple matter of adding the risk factor sheet and then doing an assign. In this particular case, we're lack of startup technicians, and then we can just do a fill down. So it's fairly straightforward. Again, it's been dealt with in other videos, so I didn't want to go through and do it now, just to show you that it has been done, and this is kind of what you look for. The only thing of particular interest here is in the piping, where we have multiple assignments. And again, that is not a difficult thing to do with the assignment. You can just do multiple assignments, and I did show some correlation here, and that's altogether subjective, but that's not really the purpose of this particular exercise. So we've done that, we've run our distribution, and now this is our results. And as you can see, this is pretty much what you would expect. And so it seems to be working. I hope you find this useful. And if you don't, or you find anything wrong with the methodology or the application, please let me know. Thank you.